Welcome back to the project display. We're going to be continuing with electronics and communication department. They have some amazing projects ready, and we will start by playing the HOD videos followed by the project videos.
Hello, I am Dr. Aarti R. Shankar, heading the Department of Electronics and Communication Engineering from the BMS College of Engineering. This department started way back in the year 1971, and the legacy of the department is continued till now. And many of the senior professors who are eminent academicians have led this department. And today, the department stands as one of the prime departments of the institution, and we have a faculty strength of 44 members who have at least 50 to 60% of them have an experience of more than 2 decades. And the department has an intake of 180 students, and totally we have around 724 undergrad students and 200 postgrad students and around 80 research scholars. This is a recognized research center of Vishveshwaraya Technological University. Coming to the research contribution from the department, we have research labs, dedicated research facility in the domain of VLSI and engineering in association with IESA. And we also have another R&D lab in the domain of RF and wireless communication. It is co-founded with the industry Keysight Technologies. So other than this, the department also has an active students club called as LSOC, who continuously on a continuous basis do lot of activities and workshops, and we have a very good alumni connect. And periodically we do have alumni interactions and expert lectures through LSOC. The department has its own newsletter which is going to promote the talent and the achievements of the students as well as faculty. So the department, from academic perspective, we have included the courses which are into the core engineering, interdisciplinary, and we promote project-based learning. So students are very much engaged when they're encouraged to perform all interdisciplinary projects, and they do a lot of contribution towards this, and it is promoted. So the project based learning is inculcated right from the 3rd semester up to the 8th semester. So this way the department tends to contribute to the holistic development of the student. Thank you.
As the world stands today, data is a very important entity, and data usually lasts longer than the systems handling themselves. So, data being so important, how do we maintain the integrity and security of such important entity in hardware systems? Most of the processors and microcontrollers available in the market don't incorporate hardware accelerated encryption or decryption units. This leads us to incorporating coprocessors or external decryption encryption units, which leads to latency when we have to handle large amount of data. With this idea in mind, we came up with the design of a RISC architecture based processor which incorporates hardware units for encryption and decryption, and also an I2C serial communication. So coming to the data and control algorithms, the control unit fetches the instruction from the instruction memory, decodes it, and sends corresponding control signals to the ALU or the I2C or the AES blocks. Now once the execution of the corresponding instruction is done, the data is written back to the data memory and the next instruction starts. Coming to the design of our processor, there is a 16-bit instruction memory bus, there's a 16-bit data bus, and also a 16-bit program. Now coming to the AES encryption and decryption unit. Now this is implemented using a FSM approach. There are 4 stages in the FSM, or states. Now once the encryption has to be done, it happens in a single FSM block. So when the encryption algorithm has to approach, the key generation happens parallelly along with the encryption, and it executes in multiple cycles. Whereas when the decryption algorithm has to happen, the key has to be generated in a reverse manner, That's why the key generation happens first and then the decryption block continues. Coming to the block diagram of the AES encryption, the state machine acts as the control unit for the AES block, and there's a key generation block which generates key, and then there's a 10 rounds of encryption which happens. There's a mod 12 counter which keeps track of the number of rounds elapsed and also a reset state, and then the corresponding data is sent to the encryption or decryption unit, and there's a multiplexer which selects either the decryption or encryption depending on the opcode being provided. Moving on to the I2C communication algorithm. This is implemented using an FSM approach again, but it has eight states in it. The I2C algorithm supports single master and multiple slave devices. The master initiates the communication by starting the bit. It pulls the SDA line low when the SCL line is high. This initiates the start of the communication. The address of the slave which it wants to communicate with is sent on the SDA line, and the corresponding slave responds back with an acknowledgement bit. And once this is done, the read or write bit is sensed, and corresponding operation is performed by the master in cycles of 1 byte each. And once this is done, there's a stop condition also indicated by the master by pulling the SDA line high when the SCL is active, and this ends the communication. In this way, this whole project is sensed.
With the advancements in IoT and artificial intelligence, smart cities is becoming a future. We, the team, have taken down the idea of water system distribution in a smart city. So, coming to the recent days wherein audit system has been completely manual, we have certain pipelines laid down across the city, and detecting the pilferages or leakages is very tough since there's no proper communication between two different pipelines, as in where the leakage is happening or where the pilferage is happening. Water being an important resource is something that needs to be conserved. So with this, we have set up a smart water audit system using IoT. So we have used four platforms for this. One being the ThinkSpeak Cloud, other being the MIT app companion, wherein we could develop an app for the users to use the app. And then we have the Firebase, which stores a database of all the users. And we have the Arduino IDE, through which we program our microcontrollers. So coming to our block diagram, so basically in a city we have a main water tank which supplies to the entire city. So the main water tank is connected to various houses via pipelines. So we have equipped each pipeline with water flow sensors and a solenoid valve. So whenever the user needs a particular amount of water, he uses the app, enters the amount of water he requires, pays for that particular water, and then just this particular thing goes to the cloud. So this data is going to the cloud. From the cloud, the main tank solenoid valve is actuated and the water is released from the main tank. So constantly, how much ever water is being flowed out of from the main tank is constantly being recorded by the water flow meter. Cloud. So from this, we get a proper tabulated data of how much water is being used by each house and how much water is being sent from the main valve. Now coming to the pilferage or leakage detection. In current days, it becomes very difficult to pinpoint the exact position where leakage happens. So in the current, so with the water audit system, just taking the difference between the value that's flown from the main tank and the subsequent flow water flow meters, we are able to detect the exact place wherein the water pilferage or leakage has happened, so that the team can go to that particular place and take immediate action. So through this way, we are having a complete accountable water transfer, saving each and every liter of water. Thanks. Coming to the demo of a project. This is the app we created using MIT App Companion, where the user can enter his user ID and password to log in. Now the user enters the amount of water he needs in liters. Simulating a payment success, we continue. Now the user presses confirm in order to confirm the water he requires. Now in the cloud, we see that the water required is updated to 0.5 liters. And here we notice that the main tank solenoid valve is open. The water starts to flow from the main tank into the home tank. As the water flows, the water flow meter present in the home tank and the main tank keeps recording the amount of water that's flowing and passes on the data to the cloud. Here we are seeing the concurrent data that's getting filled up at the home tank. And here we see the data that's being released from the main tank. Once the amount requested reaches, the solenoid valve at the main tank and the home tank stops. So we have recovered around 620 ml of water. As shown in the cloud, at the home tank we have received around 0.624 liters of water. And from the main tank, around 0.733 liters has come out. The difference in the water between the main tank and the home tank is due to the leakage between the pipes and the water that is still remaining in the pipeline. Thank you.
That was a lovely explanation, Priyanshu. I have a couple of questions for you. Am I audible? Priyanshu?
Yes, yes.
Okay. So, for any of your juniors who want to go in the same field and want to do some project, what advice would you give them, or where do you think they should go, or who do you think they should approach to do a project like this?
Okay. Regarding the project which was done, which was on water management systems, it was very important that we try to understand the current demand, which is about how can we build innovative solutions to solve social problems. So apart from that, since our college allows these projects and innovates and supports this project, we have various departments in our college, which includes department committee and various clubs which supports these initiatives. So those were the places which they can approach for.
Okay. And where do you think your project would go in the future? Where do you see your project going in a couple of years? How do you
Yes,
think it's going to be useful?
yes. Given the right support and given the right information with being captured along with association with various agencies in and around Bangalore, which includes your government agencies and national and international organizations, the project has capability of expanding into solutions which are evident, which can actually solve the problem which we are aiming towards.
Okay, thank you so much. Now we'll go on with the third project from EC department.
If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. Wireless power transmission is probably what you imagine it to be. Power sent from one location to another wirelessly. This could open up a whole new range of possibilities. However, we have been more focused to solve the problems of batteries in IoT. We plan to eliminate them from the IoT devices. Yeah, so that was an introduction about the idea behind my startup. It was basically wireless power transmission. I've developed various antennas, various phased arrays, various microstrip phased arrays on like for various different frequencies, mainly focusing 2.4 gigahertz. And I've also developed various retina circuits for microwave frequencies. So the basic idea is to transmit the electromagnetic waves and convert them to electricity. Yeah, so that was the basic about the project that we have been working on for a few months now. Thank you.
Thank you all for joining. That was the Department of Electronics and Communication. We will have the Chemical Engineering Department show their projects at 2 o'clock, so do tune into that. Thank you. Welcome back, everyone. So we're going to continue the project display with the Chemical Engineering Department. The HOD of this department is Dr. C.T. Puthuswamy, whose video you will see next, introducing the department. We have three projects in this. One, temperature dependent analysis of solid oxide fuels by G. Vishnutej, of application of nano-sized carbonized by Reshwan M. And Jyoti S will be presenting extractive distillation of acetic acid. So now we have the HOD video followed by the project videos. Let's see what we've got.
Good afternoon. Myself, Professor C.T. Puttaswamy. I am a professor and head in the Department of Chemical Engineering. The department is started 1995 and then almost 2 decades we are completing in teaching in the department. Our students are placed in various industries, chemical industries even like HUL and Desmet, Ballesta, and so many other pharma industries like that. We would like to inform you that department is created under Washington Accord Tier 1 format for 5 years consecutively times, and department is well equipped with the state of art equipments for conducting research, and the department has got a 11 faculty with a PhD, all are doctorate from reputed institutes. Our aim is to cater to students whatever they need best, and all the facilities available student can make use effectively, and we can handhold the students whatever they required for their development of the growth. Apart from that, we are providing the real industry problem oriented projects for our students. Apart from the general curriculum, our curriculum is a robust as compared to other universities. Our motto is to become number one in the Karnataka, the department actually. I welcome the students to come to our department for studying chemical engineering, graduate and get benefited from the service facility available in the department. Thank you.
Hello, my name is Reshwantam Bhagyawadi, 7th semester from the chemical department. My project is the applicability of carbonized sugarcane bagasse in reinforced concrete. Concrete is one of the most extensively used material worldwide, but has a major negative impact due to the emission of carbon dioxide. Availability of surplus agro residues like sugarcane bagasse can be used can be converted to the biochar, which can be used as a concrete fillers. This reduces the emission of carbon dioxide with less use of cement, and it also increases the quality by hydration and microstructure. The aim is to study the applicability of carbonized sugarcane bagasse in reinforced concrete. The objective is to prepare a carbonized sugarcane using the sugarcane bagasse and to study the characterization and the pozzolanic activity of the biochar and to perform the break-even analysis of the sugarcane bagasse blended with the concrete. The materials required are shaft cutter, grinder, hot air oven, muffled furnace, and sugarcane bagasse. The sugarcane bagasse is pre-treated before sent to the muffled furnace. The pyrolysis takes place in the muffled furnace to produce the biochar. Simultaneously, the characterization and the pozzolanic activity study. Uh, Simultaneously, the characterization and the pozzolanic activity of the biochar is held, and the biochar is mixed with the reinforced concrete to study the break-even analysis. The market price of M20 grade concrete is rupees 3,800 per meter cube. The operational cost is 30% of the total cost. The fixed capital cost is the sum of cost of mixing and the operational cost, which is again the 30% of the total cost. The variable cost is the sum of purchase cost of cement, brick material, and the filler material, plus the cost of biochar production. In conclusion, necessary testing was done at a laboratory scale to obtain the biochar. Detailed study was carried out to show the bagasse char is suitable for concrete production. Bagasse is a class F pozzolan due to high silica content. Sugarcane has the high proportion of cellulose, hemicellulose, and lignin that influences the production of biochar. And the break-even analysis was carried out to show economic feasibility of the process. Thank you.
Going on. Thank you so much. That was a lovely explanation. We have Vishnu here who will be answering a few questions. Hi, Vishnu. Am I audible?
Yeah, I can hear you. Can you hear me?
Yes, I can. So, any project that is done, we all know that we experience some kind of obstacles or failures as we are doing it. What would you say was like the biggest obstacle you had to overcome as you were doing this project?
So, as our project involves solid oxide fuel cells, which is currently a developing technology. So, being students, I could say that we face certain challenges in acquiring the software and doing literature survey because very little research has been done currently. Like what the idea we had was to do temperature analysis, and very little research has been done in that particular aspect. So, doing the literature survey, getting the relevant material, and acquiring the software are some of the major challenges which we had. And then to, of course, analyze where we went wrong because it was a first time project. It was introduced in the fifth semester for us. So, those kind of challenges we had faced.
And how effectively do you think you overcame these challenges, and how did BMS like help you do this?
Yeah, so I mean, we are actually grateful to the college curriculum for chemical engineering curriculum to include mini projects into our scheme because we could actually make time because since it was in our curriculum to do these kind of projects to go ahead with it, and we are really grateful to Dr. Samita Mehta ma'am for guiding us with throughout the project, letting us know where we are going wrong and what could be done better. So because of implementation of this particular project in our scheme, we were able to do it better at the end.
Thank you so much. It was lovely having you. We will move on to the next project.
So, good afternoon. I'm Jyoti S. from 7th semester Chemical Engineering Department. Our project is about the extractive distillation of acetic acid from benzene using water as a solvent. The extractive distillation is normally different from the normal distillation because the distillation which we employ cannot separate the azeotropic mixture since both the components in the azeotrope will have the same boiling point. Hence, extractive distillation is employed using a solvent. The solvent will relatively change the volatility of the azeotrope so that the separation is favorable. Our flow sheet will include a mixer, two distillation columns, a cooling tower. In a mixer, a recycled solvent as well as a fresh solvent is mixed, and along with it, the feed mixture is sent to a distillation column. The feed will include the benzene and the acetic acid. The distillation column. It is an equipment used to separate the mixture based on the difference in the relative volatility. The distillation columns have provisions for feed and removal of the top product and the removal of the bottom product. The section above the feed entry is called the enriching section, and the section below the feed entry is called the stepping section. Inside the tower, there are a number of trees. There is a downcomer, so that the liquid will be flown from one tower to another tower, and there is a weir to hold on the liquid for a certain height. The feed, which is acetic acid and the benzene mixture, when it is sent with the water, their relative volatility will be changed, so that the product which is obtained is the top product is the benzene and water, and the bottom product is acetic acid. Acetic acid will be removed from the bottom. In this distillation column design, we have made use of the Machiavellian method in order to find the number of stages. The conventional method using the handmade complication graph. In order to avoid so much of complications, there is a method which is developed using an Excel sheet. First, we draw a graph of mole fraction of the feed in the liquid phase versus the mole fraction of the feed in the vapor phase. First, we draw a 45-degree line, that is an operating line for the total reflex. Then an equilibrium curve is drawn using the VLE data for acetic acid and the benzene mixture, which is obtained from the Perihand book. Now, we need to find then operating line that is drawn from the 45-degree line and the equilibrium curve, which is called as the Q line. And there is a line, operating line, which is drawn at the XD, that is the distillate mole fraction, and XW, the mole fraction of the residue. Operating lines between the feed and the mole fraction of the distillate is called the rectification line, and the operating line between the residual mole fraction and the feed is called the stripping section operating line. There are a set of formulas that are formulated. Once which is all the formulas are entered in an Excel graph sheet, there is need not they need not to be drawn again and again. Once the mole fractions are changed, we can automatically get the operating line for the enriching and the stripping section. The theoretical number of stages are drawn between the equilibrium curve and the operating line. For the first distillation column, the total number of stages obtained is 20, and the feed stage is 12. Now, the top product from the distillation column one is the benzene and water. Now, they need to be separated. So, the distillation column second is employed. The same procedure is followed. In the distillation column, the main objective of using a bubble cap is used. Bubble cap diverts the vapor flow above the liquid level on the tray deck, so that there is a thorough contact between the water that is liquid as well as the vapor phase. From the second distillation column, the top product obtained is benzene, and the bottom product obtained is water. In order to not waste the solvent, the water has to be recycled. The water is cooled using a cooling tower. The water which is coming out of the distillation column at the temperature of about 45 degrees Celsius, we decide it to be cooled to the 30 degrees Celsius. We employ a cooling tower. Cooling tower is an equipment which is used to reduce the temperature of the water by countercurrent operation with the air through the tower packed with the wooden slats. uh, the air has a dry bulb temperature of 31, and the wet bulb temperature of 22 degrees Celsius. The hot water is sprayed from the top of the cooling tower using a distribution tower, whereas the air, it is countercurrently passed from the bottom, since the density of vapors or air is very much less than that of the incoming water. There is a mass transfer taking place between the air as well as water, so that the water rejects its heat to the air and will be collected from the bottom. The air, which has now become hot, will be cooled to some lower temperature by employing the number of fans in the cooling tower, and then rejected to the atmosphere. Now, in order to find what is the dryer flow rate to be used and the package height of the wooden sleds, we make use of the graph of enthalpy versus temperature. Since the cooling temperature is 30, we draw a graph of temperature swinging between 25 to 45 with their respective enthalpies, which are formulated by making use of the psychometric charts, so that we get an equilibrium curve. We mark a point called Q at 30 degrees Celsius with its respective enthalpy and draw a tangent to the curve. And the slope of the tangent will be equal to LC by G, where L is the liquid flow rate with which the water has coming, and C is the capacity of the heat capacity of the water, that is 4.187 kilojoule per kg Kelvin, and G is the minimum gas flow rate to be used. From this formula, we will get what is the minimum air flow rate to be used, and the operating flow rate must be equal to 1.4 times the minimum. Now, in order to find the height of packing, we make use of another point called P. So that let that point be marked on the tangent line Q, so that the tangent gets shifted away from the equilibrium curve, the operating line PQ, and the equilibrium curve. We need to draw the tie lines between these two curves. The slope of the tie lines is obtained by the formula slope is equal to h by k, where h is the heat transfer coefficient and k is the overall gas mass transfer coefficient. Since both the h and k is known, slope of the tie lines will be obtained. It is equal to minus 11.4. Using this value, we get the tie lines. From these tie lines, we get two enthalpies value, one on the operating line PQ, let it be called it as H dash, and one on the equilibrium curve, let it be called it as HI dash. We draw another graph of 1 by HI dash minus H dash versus H dash. We get a curve. The area under the curve gives the number of transfer units, that is the theoretical number of stages required for the cooling tower, and the number height of the transfer unit is equal to k by g, where I said before k is the overall gas mass transfer coefficient and g is the minimum gas flow rate to be used, that is already found. Using this formula, we get the height of the transfer unit. The total packing height will be equal to the number of transfer unit and the height of the tower, which comes around 3.83 meter. So this is about the cooling tower designs. And the two distillation columns which we have employed, the diameter comes around 1 meter and height comes around 3.5 to 3.8 meters, so that the design condition, that is h by d ratio must be equal to 4, it is satisfied, so the design of the distillation column is satisfied, cooling tower is also implied. So this is all about the simulation of the entire extractive distillation of acetic acid from the benzene using water as a solvent.
That was a really, really informative project. I think we have Jyoti's teammate Rakshita over here who will be answering the questions. Am I audible?
Yes, ma'am, you're audible.
Okay, so as you know, chemical engineering is an extensive field, and it has a lot of elements to it. And how would you help your juniors who would want to go into this field or do something similar to this?
Yeah, chemical engineering is a unique field in which we learn about the production of different kinds of chemicals, manufacturing, and also we learn about the design of the equipments. um, yeah, for my juniors I would like to regarding our project I would like to guide them about the simulation softwares which we used in our project. DWSim is the software which we used, through which we can build the unit operations, and we can solve the problem in a easy way. um, it is not possible for us to conduct all the chemical engineering experiments in reality. So using simulation the problem we can solve through computer or the software when we put set of scientific equations, and we get a workable solution. So it is a great software through which we can solve the problems. It also help to study the steady state and dynamic models for the plant designs. And also we used for graphs we use the excel. We cannot manually draw the handmade graphs, so when we put the set of scientific equations into excel, so we get a proper graph uh, for the different values. So it is a this is what I'd like to say.
Yeah, I think we can all agree that software does really help us a lot. That was really informative. Thank you. Now we move on to the third project by
Thank you.
Vishnu.
Hello all, I am G. Vishnu Tej from Chemical Engineering Department final year. The project which we undertook in for simulation was temperature dependent analysis of solid oxide fuel cells. Now, I'd like to speak about what was the motivation behind selecting this particular subject. So, in this era, as we are aware that fossil fuels are fast depleting, which calls for an urgent need and improvement in renewables. And solid oxide fuel cells serve as one such answer. Solid oxide fuel cell is an electrochemical cell which converts the chemical energy of the fuels, wide variety of them, in fact, and converts them into electrical energy, which aims at meeting our demands. Now, I'd like to speak about our simulation part. So, to begin with the simulation, first you can see that we have created a 2D file, 2D object in our ANSYS Space Game software and extruded it to 3D. Then we aim at transferring this CAD file to COMSOL multiphysics software, wherein we'll do our entire simulation. Here, we aim at taking this particular CAD file and assigning the probe boundary conditions to it. The probe boundary conditions include assigning the anode probe boundary conditions for the hydrogen as a fuel, the probe boundary conditions for oxygen as the other fuel, and proceeding on with water formation at the end of the reaction, electrochemical reaction. The hydrogen water probe boundary condition is assigned at the anode. Following this, we aim at following this assigning the probe boundary conditions, we aim at selecting the materials required for our study. So, firstly, we select nickel oxide based ceramides as an anode material, and for the electrolyte, we choose yttria stabilized zirconia, and for the cathode, we use lanthanum strontium cobalt ferrite. And the choice for these materials was driven by our literature survey performed before. After selecting of the materials, we proceed with selecting the physics for modeling our particular simulation. It consists of three particular physics which are to be chosen. The secondary cell current distribution physics, which involves selecting the Butler-Volmer equations for charge transfer kinetic modeling in the anode, the cathode, and the electrolyte, because that's the most fundamental equation for modeling the same. Then we go ahead with the transport of concentrated species, which involves the use of Maxwell-Stephen diffusion equations for modeling the flow of these species in the respective electrodes and the electrolyte. Then we go for the wait one sec. Oh, okay. So we first select the transport of concentrated species physics, wherein we are modeling the same. We're trying to model the pressure fields and the velocity fields in the electrodes and the electrolytes using the Navier-Stokes equations and the Brinkman equations. Then the flow of the concentrated species in the electrodes and the electrolytes is modeled by the means of Maxwell-Stephen diffusion equation. After these physics are selected, we aim at meshing our particular model, which is a normal meshing done here for finite element analysis to obtain the results. After meshing has been done, we go to the study mode, wherein under the study mode, the computer requires setting certain parameters. Majority of the parameters are set based on the literature survey, with temperature being the only variable parameter for our studies, which will be shown later in the results section. And after these parameters have been set up for the study mode, the simulation is started. As you can see here, the simulation is being run. It takes some time for the simulation to occur. Then after a period of time, the results are obtained. Under results, we will bifurcate them into two particular segments. The one which talks about the polarization characteristics, the other which talks about the power characteristics. Now, as you can see on, first of all, I'll speak about the polarization characteristics. There are a number of curves obtained, in fact, four of them, which are at 500, 800,000, and 1200 degrees centigrade. And we can see that as you increase the temperature of the SOFC, operating temperature, the performance of the SOFC increases in the fact that the polarization voltage required for the operation of the SOFC is lower at a higher temperature. And next, we'll talk about the power characteristics. Under power characteristics, again there are four different curves obtained because our simulation study was performed at four different temperatures. Under this, we can again see that the average cell power required for the operation of the SOFC decreases with the increase in temperature, again attributing to the fact that the performance of SOFC increases with increase in temperature. Therefore, I'd like to conclude that throughout our simulation studies, we were able to find out that overall performance of the SOFC increases with the increase in temperature. And our further studies, as a further study, we could also be interested in focusing upon trying different materials out so that we can work out with the operating temperature of SOFC. Thank you.
Thank you, Vishnu, for the project presentation. I think we have Vishnu here.
Yeah, am I audible?
Yeah, yeah, you
Yeah,
are.
okay. Thank you.
So I have I have two questions for you. The first one is, what do you think? What was your motivation, or what did you think before starting this project?
So as we can see, currently the entire focus is shifting on exhaustion of fossil fuels to getting a more sustainable alternative to it. Like even recent coal crisis of India is also pointing towards the same. So keeping those kind of things in mind, we thought like the future is renewables, and in that solid oxide fuel cells are like one of the most versatile fuel cells because they can take in any wide variety of fuels and convert them into energy, which makes them all the more alternate best possible alternative to current energy demands. So we thought we could work on simulating the temperature dependence of solid oxide fuel cells because from literature survey we found out that operating temperature of SOFC is pretty high, and it is a necessary evil also because its performance also is best at its highest operating temperature. So in order to model the same and study why exactly this is happening and what are the reasons and how can we work on it, we took up this particular project.
So you were trying to look for a more eco-friendly option for what
Eco-friendly
you want.
sustainable option, yeah, which could be implemented at household level as well, because the current operating temperature of SOFC means makes it seem like it's suitable for industrial scale or something, but our idea is to scale it down, get it towards household level as well.
That is interesting. Where do you see this going in maybe 5 to 10 years?
Uh, See, because as of now, since the fossil fuel-based sources are fast depleting in nature, people are looking for a very various type of renewable energy-based alternatives. So windmills are very evident there. Hydrothermal, tidal, geoenergy, all these kinds of energies are very available. And fuel cells are like those compact entities which meet our energy demands and which are capable of meeting our energy demands at convenience. Like they can be installed anywhere, used anywhere. Currently, if you can see in vehicles as well, Toyota Prius, they are using hybrid engines for applications. Though they're using proton exchange membrane-based fuel cells for meeting their energy needs, SOFCs are another viable alternatives because of their ability to take in wide variety of fuels. So we maybe as far as our viewpoint is concerned, my group's viewpoint is concerned, maybe in the vehicle sector it can be implemented, or maybe in various power grid distribution energy sources. So in the future, it may meet our demands, and it
Okay.
has the
Yeah.
potential to do so. Yeah,
Hopefully you can scale this up.
yeah. Thank you.
Thank you for being here.
Yes, and we'd
This
also like to acknowledge our guide, Dr. Samita Mehta, for motivating us to do this particular project and providing assistance to us. Yeah,
yeah,
that's all.
thank you.
Yeah, thank you.
Um, that with that, we come to the end of the project by chemical department. We will be starting again at 3 o'clock with the EIE department. So hope to see you all there. Thank you. Welcome back, everyone. So we have the projects of the EIE department that are going to be presented now. Um, so we have Sudarshan, Swati, and Haida from EIE department who will be presenting their projects.
Hello everyone, I'm Dr. Veena Hegde, heading the Department of Electronics and Instrumentation Engineering. The program of instrumentation technology started in the year 1991. We have been renamed as Electronics and Instrumentation Engineering from the year 2014. Presently, we run with an intake of 60, and in the department, we are a team of 11 faculty members. Four of us are PhD holders in the department, and we do guide the PhD students. The department has a good industry connect. Each faculty here are well connected with the industry. We practice outcome-based education and have been accredited by NBA, and all our faculty members offer various industry-defined projects and real-life problems to students. And here in the department, students get to integrate with well-defined industry problems with their regular curriculum. And mainly, our courses are involved with more of sensors, automation control, and design experiments. And students get to learn a lot of applied engineering problems and practices. And at the end of the day, I wish to say that as a department, we make our students graduate with good engineering competency and also professionalism and an ethics.
Good morning, I'm Swati from Electronics and Instrumentation Department. Our project is food quality detection and monitoring. More than 50% of the food gets thrown away to landfills because of wastage or improper maintenance. Stop this and also to stop hunger, we've engineered and designed this system. This can be implemented in airplanes while we are exporting the food, in warehouses, storages, and also in malls to extend the shelf life of the food. Basically, we've used three main sensors to detect the food quality. That is DHT11 sensor, MQ6 sensor, LDR sensor. DTH11 is a temperature and a humidity sensor, and MQ6 sensor detects foul gases or from ethanol and alcoholic smells. An LTR is a light sensor and it detects ambient light or not. This our food quality detection system will all help in detecting the food if it is spoiled or not, and also will help us in monitoring the environment. In case when there is a rotten apple along with good apples in a basket, it shows through smell MQ6, it will show the food is spoiled, and we get a message on our LDR saying abnormal smell, and we can remove the one of the apple instead of letting all the apples get spoiled. Similarly, we have other parameters also, that, such as light. When there is an abnormal lighting, that is when light is out of range that is specified by us, or also the temperature and humidity that is out of range of the system. It will also help us monitoring this environment by increasing the temperature or by decreasing the lighting. If there is too much lighting in the environment system, the chances of food getting overripe also increases. We have used an IO. So the for the software part, we have used Arduino, and we have programmed using C programming in the Arduino. And also we have used IoT, the think and speak. And then when our food quality system detects
Hi everyone, I am Sudarshan Azra from the Department of Electronics and Instrumentation, and I am here to explain my project, Prosthetic Arm for Rehabilitation Robotics. So what is a prosthetic arm and why is it used for rehabilitation? A prosthetic arm is basically a replacement for an arm if an arm is cut off, and then it helps all amputees to enhance their mobilities and also their capacity to carry out day-to-day activities like cooking or walking, writing, and also allowing them to remain independent. So in our project, we developed a hardware setup for first signal acquisition, Then we developed a code to realize the servo motor actuation to replicate the real life muscle movements. To be specific, we recorded the movement of my right hand's wrist from 0 to 90 degrees. The scope of our project is to basically provide a cost-effective system, a cost-effective prosthetic arm to all amputees. We verified an existing system called as Skull Arm. It was developed by a Hyderabad institute, which is basically a 3D printed bionic arm. It is a lightweight 3D printed bionic arm. It cost around 35 lakh rupees. So if we wanted to create a cost-effective solution for this, we aimed at replicating the same results provided by the Hyderabad's bionic arm. So coming to the hardware implementation, first we analyzed an online repository to figure out what kind of data we are dealing with, because while we are working with human hand over here, which is which safety is the imperative system over here. We took an online repository, the data from an online repository, and then we applied a lot of classification algorithms on RStudio. We got 91% accuracy with KNN, that is K nearest neighbors algorithm. We also used K-means, but we received only 89% accuracy. Although K-means was faster than KNN, since our data set was small, and then we got a lot of accuracy with KNN. We used KNN classification algorithm. Later, we realized that data in both time domain and frequency domain. And then coming to the servo motors part, we attached several electrodes on the right arm. The electrodes are basically used for EMG, that is electromyography. Electromyography basically produces a waveform when there is a movement in the hand's muscle. And then we also used the EMG clip. EMG clip is basically used for signal conditioning. It had two RC filters to remove any noise from the signals, and then it also had an amplifier to amplify the signal, because the output of any EMG will be in millivolts. We had to amplify it to volts. And then later, after amplification, we passed it to a comparator, where the comparator compared the data set to a threshold value, so that we reject all the unnecessary values and then take only the values which were required for our experiment. And then later on MATLAB, we compare the coefficients of our data sets to get a smooth bell curved graph, because when we took the raw data and we plotted out the graph was very skewed. We wanted a perfect bell shaped graph, so we did that. And then later we gave a PWM, that is pulse width modulation input to the servo motor, so that it can replicate the exact movement of the wrist, and then we achieved very good. We achieved a very good output with the servo motors, but unfortunately due to COVID and less time, we couldn't do for the entire arm. We just used the wrist motor. Thank you.
Hi, I am Mohammad Muzaffar Haidar from Department of Electronics and Instrumentation.
I am Laika Anje from Electronics and Instrumentation Engineering Department.
Here we are to explain our project, study of gesticulation-based activation of computer application. Basically, it is a system which uses hand gesture to control the computer applications. We are use Arduino ultrasonic sensors, Arduino, which is connected to the laptop, and Python libraries, which are Python PySerial library and Python orthographical user interface libraries. Basically, the ultrasonic sensors will be connected to the either end of the laptop. Then it is connected to the Arduino, and the Arduino is connected to the laptop. Ultrasonic sensor senses the distance of the hand from the ultrasonic sensor, which is calculated using Arduino, and it is sent to the laptop using PySerial library. In PySerial in laptop, using a Python graphical user interface, the hand gestures is converted to the keyboard, mouse and keyboard click actions.
So we have implemented this project using two computer applications, that is web browser and VLC media player. There are various gestures which we included in our project, like suppose we keep our hand in front of the right ultrasonic sensor and move it away or towards the sensor. It will lead to the action of scrolling up and scrolling down in the web page. And similarly, when we keep our hand in front of the left ultrasonic sensor and move it towards or away from the sensor, it will lead to volume up and volume down in VLC player. And when we swipe our hand in front of the right or left, it will lead to next tab or previous tab. And for playing and pausing the video, we need to keep both the hands in front of both the sensors. And this project is mainly used to solve the problem of traditional HMI devices like mouse, which usually requires a surface to operate on. And since these surfaces may not be available always and they cannot work on rough surfaces also, hence by using gestures to control the computer application, it will be easier compared to that. And it can be used while doing presentations or in teaching, where the teachers have to continuously change the slides while teaching in class. And it can be used for gaming applications also. Thank you.
Video demonstration of the project. This is the setup of our project. Two ultrasonic sensors are placed on top of the screen on either ends, and they are connected to Arduino Uno, which is placed on the back of the laptop. This is the Arduino Uno. The trig and echo pin of sensor 1 is connected to pin 2 and 3, and trig and echo pin of sensor 2 is connected to 6 and 5 of the Arduino. The Arduino code is uploaded and the Python code is left running in the background. First, we'll be performing actions in the web browser. For changing to the next tab, we need to swipe our hand in front of the right ultrasonic sensor. For going back to the previous tab, we need to swipe our hand in front of the left ultrasonic sensor. For scrolling up the web page, we need to place our hand in front of the right ultrasonic sensor and move it towards the sensor. For scrolling down the web page, we need to place our hand in front of the right ultrasonic sensor and move it away from the sensor. Now let us look at the actions performed in VLC player. To play the video, place both of your hands in front of both the ultrasonic sensors. To pause the video, again place both the hands in front of both the sensors. To increase the volume of the video, place your hand in front of the right ultrasonic sensor and move it towards the sensor. To decrease the volume, place your hand in front of the right ultrasonic sensor and move it away from the sensor. To rewind the video, place your hand in front of the left ultrasonic sensor and move it towards the sensor. For forwarding the video, place your hand in front of the left ultrasonic sensor and move it away from the sensor. Thank you.
That was the EI department. Thank you so much. Now we have projects of
Ramesh Naik, Head of the Department of Industrial Engineering and Management. Department of Industrial Engineering and Management established in the year 1979 with the intake of 60 students. I think we have 11 faculty. Out of 11 faculty, 7 faculty already completed PhD. 1 faculty is in the verge of submission of the thesis. Another faculty is pursuing PhD. We have vast experience of faculty having different researches like ergonomics, quality and reliability, composite materials and cryogenic applications, facility planning, and supply chain management. And we have the student club, industrial engineering club. In that club, students having many activities. We can have that technical talks and sports activities and other. We can organize other events also. And we have the placement cell from the department, and we are organizing internships and placement activities from the department. In the 2019 and 20, four students placed in Jumbo Tail company, and 2020-21 and nine students got internship. Few of them already converted into a job. This year one student already did the internship in the Jumbo Tail company. And Phaseshift is the technical event. This many years we are organizing from the college.
Start. Hello, good evening. This is Gaurav Nitrekar. I am from IM department, currently studying in third semester. This is the project done by our seniors. I'm gonna illustrate about it. This is rapid prototyping. So, rapid prototyping is a group of techniques used by quickly fabricated using 3D images and converting into CAD data. So, can, rapid prototyping are also referred as layer manufacturing, so material addition. So basically, there are two types of additive manufacturing. First one is additive manufacturing. Additive manufacturing is a layer by layer manufacturing, and separative manufacturing is subtracting the materials layer by layer. There are more types of techniques in rapid prototyping. First one is STL, which is stereolithography and laminated object manufacturing, selective laser sintering, and fused deposit modeling, solid ground curing, and 3D inkjetting. So coming to first, STL, which is stereolithography. So stereolithography is a laser-based rapid prototyping process which built after directly from CAD by curing or hardening a photosensitive resin with a relatively low power laser. So coming to advantages of stereolithography, parts have best surface quality, high accuracy, and high speed. And finally, detailed features like thin vertical walls can be seen. And applications are investing, casting, wind tunnel modeling, tooling, and injection mold tools. So yeah, deposition modeling. So yeah, so nozzle head of FDM is attached to a mechanical chassis which uses belt or lead screw systems to move it. The entire extrusion assembly is allowed to move in XYZ dimension by monitorized system. The fourth motor is called as the step motor is used to advance the thermoplastic material into the nozzle. As the nozzle is moved towards the table in the required geometry, it deposits a thin bed of extrude plastic to form each layer by layer. This plastic hardens immediately after being squirted from the nozzle and bonds to the layer below. The object is below is on a mechanical stage which moves vertically downward layer by layer as the part is formed. The entire system is contained within a chamber which is held at a temperature just below the melting point of the plastic. So yeah, advantages of FDM. FDM can reduce lead time and poor dimensional accuracy that are associated with traditional pattern making. The process is accurate to within 0.005 inches. So yeah, every system got a limitation. So FDM also has its own limitation, which is sharp features or corners not possible to get. Part strength is weak perpendicular to build axis. More area in slices requires longer build times. Yeah, 3D inkjet printing. Unlike the other above techniques, inkjet printing refers to an entire class of machines that employ inkjet technology. The first was 3D printing, developed at MIT and licensed to Solution Corporation. And yeah, that's about it. 3D inkjet printing. Ground Curing (SGC) was developed by Cubital Limited, which is jointly owned by Harvix GmbH, Clal Electronic Industries. In this process, the firstly photosensitive resin is sprayed on the build platform. Next, the machine develops a photo mask of the layer to be built. The photo mask is printed on a glass plate above the build platform using an electronic process like that found in photocopies. So next one, last one is laminated object manufacturing. In this process, the laser cut the slices from a sheet of paper which is then attached to previously cut layers. Unlike other process, only the routine or outline of the shape need to be cut. But areas which are to be internal free space in the final model are finely cross-hatched by the laser, producing a collection of small cubes in the final model. Yeah.
My name is Akhila and I'm from the third semester of Industrial Engineering and Management Department. I received this topic on the design and development of an economical groundnut pod stripper from my seniors, and I'm here to elaborate on it today. So the groundnut production in India is done at a very large scale, and groundnuts are one of India's most important crops. Most of the groundnut production in India happens amongst small and medium scale farmers, and they are unable to afford the equipment for this process. It's done manually most of the times, and because of this, it's a very time consuming process, and uh, it requires a large amount of labor. This increases the expenditure amongst the farmers and decreases the efficiency as well as the revenue. So, this project aims to rectify this problem among small and medium scale farmers, and create a groundnut stripper which will work at a less operation. A brief introduction on what is stripping now, the stripping of the groundnut pod. So the process of separation of the groundnut takes uh, place after the harvesting and drying of the crop. So the objectives of this project were to increase the overall productivity, to increase the efficiency, and to make sure that the stripping of the groundnut pod was done at an efficient and in an effective manner. Are involved in the stripping of the groundnut pod. So the first step was to observe, understand, and interpret the drawbacks which were involved in the process of stripping of the groundnut. The next step involved processing of the various parameters and working on an efficient solution to to help to identify various process parameters or variables and work on it for improvement. The specifications of the automated solution of groundnut stripping would be then developed. Uh, An efficient, portable, and affordable groundnut pod stripper. This mechanism proved a high degree of efficiency, and the conclusion that was derived was that the morale of the farmers was high and the operating cost was very less. Most of the objectives were achieved, and there is a lot of scope of improvement. Technology is never constant, and there can always be refinements and improvements made in terms of the capability and stripping efficiency in the groundnut stripping pod model. Thank you.
Hello everyone, myself Rahul, Assistant Professor, Department of Mathematics. We would like to present an algorithm called singular value decomposition in face recognition. First, we will see what is singular value decomposition mathematically. So, a matrix A has been decomposed into three matrices. That is, matrix A can be written as product of three matrices. One is U, sigma, V transpose. This U contains eigenvectors, sigma contains singular value in decreasing order, and V contains orthogonal vectors. These are the dimensions for matrix A, U, sigma, and V. So the procedure is, first we need to find the eigenvalues and eigenvectors for A transpose A, and then comes the singular values, that will be the matrix sigma. Singular values are nothing but square root of eigenvalues, and then we have to find orthogonal vectors using Gram-Schmidt orthogonalization process. Now the problem is how this algorithm is used in face recognition. So what we have done here is, we have considered 5 personalities: Abdul Kalam, Kamal Hassan, Aishwarya Rai, Rahul Dravid, Virendra Sehwag. There is a database, and that contains 25 images, totally 25 images of all these personalities. So as you can see, each personalities, there are 5 different images, are with different orientations also. So the main problem is, if someone gives a new image to the database should compare the new image with all these images and give the correct image as the output. That is what the problem is all about. And the algorithm what we are going to use is singular value decomposition. Now, as we know, each images can be represented in the form of a matrix. So the first step is, we represent the images in the form of a matrix of dimension 9600 cross 25, because there are 25 images and there will be 9600 rows. Now, once we got the matrix, since to find the eigenvalues, we have to get the square matrices. So we will compute AA transpose and we will find the eigenvalues. Square root of eigenvalues will give me singular values. Now the next step is, we will consider the average phases. The average phases means, for example, if you see Abdul Kalam sir's images, first image is x1, second is x2, third is x3, 4 is x4, and 5 is x5. So the uh, average image of Abdul Kalam sir will be x1 plus x2 plus x3 plus x4 plus x5 divided by 5. So like that we are going to do for rest of the images. Now once we got the average phases, now we'll go for the eigenphases. Now what are these eigenphases? These are nothing but eigenvectors from the matrix V. So these each images are nothing but our eigenvectors. So as you can see, for example, the first image, if you see, the images of all the personalities are present in the first image. Same thing will go for the second image. And also, if you see the graph, the singular values are decreasing. That is nothing but the matrix sigma. Mathematically, when we substitute the singular values, we will substitute in the decreasing order. Now, once we got the eigenphases, now we will proceed with the image keys. Now, what is this image key? This is nothing but the template of each personalities, because when we send a new image to the database should have some template connected to Kalam sir, Kamal Hassan, Aishwarya Rai, and so on, so that the database can compare the new image. So these are the template for all the images. You can easily get the template by using inner product space. For example, to find the template for Dravid, you have to consider inner product of Dravid with first eigenvector, similarly inner product of Dravid with second eigenvector, and so on. Now once the database has the template, when the new phase comes in, the database will compare the new phase with the template already present in the database, and it will concentrate on the errors. As you can see here, when the Kamal Hassan sir's new phase comes into the database, according to the graph, if you observe, the second position, the error is very less. So database will go to the second image, which is Kamal Hassan sir. So it will output the Kamal Hassan sir's image. Similarly, when Abdul Kalam sir's image comes into the database, it will you can clearly see that the first point has less error. So the database will output Abdul Kalam sir's image. So this is how singular value decomposition is applied in face recognition. Thank you.
Those were all the projects we had today. So we covered a lot of departments, but we still have a lot more departments to cover, which will be shown tomorrow. So do tune into that. And thank you for joining. Hope you enjoyed this presentation.